Hello all. In this video, I am going to show you about the complete integrated system of an incident detection system and the battery management system which I am working on for the EVA project. So here is the battery management system complete section. In the previous video, I've explained the independent working system of battery management system and an incident detection system. In this video, let's see the battery management system. Here I'm using Arduino Uno Q, and as I explained, the voltage, current and temperature measurement system, the PCB, and I am using an RS-485 transceiver from analog devices to communicate all the information whatever it gets from the BMS onto the IDS node. And this section of the unit is powered by this 18650 battery, 2 cells of 18650 battery. It has contained with an BMS and NTC temperature resistor placed beneath this battery. So as of now, I am just giving the DC motor as a load for this system. As you see, here I am using a 4-channel relay module. In the second video, the architecture video I've explained, I am using some 4-channel relay module in connection with the RS-485 transceiver. The purpose of that I told in that video. I'll reveal it I'll reveal it in the next videos. So the main purpose of this relay module is to do a loopback connection. Actually, the analog devices, this eval board comes with a few jumpers like LK3, 4, 5 and 6, which will help us in creating a loopback between the RS-485 channels. When it comes to the incident detection system, here I am using a redundant battery also, 18652 cells, and an auto switching relay module, and an IMU sensor to detect any irregularities in the motion. Here I am using an Arduino Uno to monitor all these IMU sensors, and one more RS-485 transceiver to get data from the other BMS node. Here I am also using a 4-channel relay module to do a loopback connection of this transceiver. So here is the web interface of the complete dashboards. All the data is pushing to the web UI from this IDS system unit. It's like a master unit, and BMS is a slave unit. All the battery information getting from the BMS is pushed to the IDS master unit, and that is going to push to the web UI. Here you can see the SoC state of charge as 41%, and here also in the display it is showing as 41%, and SoH it is showing as 100%. Actually, to do an SoH, we need to collect a huge amount of data of charging and discharging cycles. But as of now, for this project, the algorithm is implemented to calculate an SoH. But it will always show 100% because there is no much charging and discharging cycle of a battery happened in this section. And the voltage I am measuring it as 7.63 volts. Current is consuming 250 milliamps. This is a total current consumption by this Arduino, BMS Arduino and the IDS Arduino. And the temperature I am measuring as 23.2 degrees Celsius. Here you can see the open circuit voltage, Coulomb count, and this is the battery capacity. It is as of now fixed 18650. And since the voltage is 7.62, it's showing as normal. When it goes above 8.4 volt, it will show as an over voltage and throw the fault indications in the web UI. And there is an under voltage also to measure when the battery goes below 6 volts, and over current to have some surge protection. BMS status it is showing as normal. Here you can see the complete log of both from the IDS incident detection system and the battery management system. If there is any unprecedented incident occurs, here we will get some notification regarding the actions to be taken or some precautionary measures. In the above status bar, you can see it is showing system active, BMS linked, power drop normal. Actually, in the IDS system, I am having an voltage measurement unit also. So basically from the BMS, I am using a Molex connector provided by the EVA kit to power the IDS system also. And I am measuring the voltage across here. The idea behind power drop measurement is like whenever the voltage the BMS sends, it will send the voltage across the battery, and I'm measuring the voltage after the connector also. Means in future when the power degradation happens, there is an increase in the resistance. So if the drop volt I am set as, if the drop voltage greater than 500 millivolt, then throw an warning regarding the connector degradation. If it goes above 1 volt, means then there is a chance of connector getting failure. So to detect this, I am making the setup of an voltage measurement on the IDS unit also. In the live graphs, you can see the accelerometer and the battery informations, voltage, current, and SoC.